Okay, question 17. Draw a histogram. Remember, frequency density, which is the vertical axis, is frequency divided by class width. The class width is the difference between these two numbers. Class width, I'll write them down here. 0 and 20 is 20, 50 to 20 is 30, 50, 200, 50. Okay, so we're going to do frequency 40 divided by 20. 40 divided by 20 is obviously 2, so we're going to write frequency density. 40 divided by 20 is 2. 90 divided by 30 is 3. 140 divided by 50 is 2.8. 140 divided by 200 is 0.7. And 40 and 50 is 0.8. Now, you need to just draw these taking into account the class width. So I can see going on 50, so 20, that would halfway be 25, so 20 is that one. So I've got 20 wide and it goes up to 2. So the first bar is that one. You're supposed to use a ruler, but I'm not going to bother because I'm in a hurry. So that's the first bar. Second bar goes up to 3 and it goes along to 50. So 3, go. Next one is 2.8 high and it goes along to 100. 2.8, it's here. 100. Next one goes to 300, so all the way over there, and it's 0.7. So 0.7. I'll use a ruler now. That goes up to there, and the last one is 0.8, and it goes on to 350. So there we are. Oh, nice easy 3 marks. So what we got to find? Work out size of angle SQR. So this angle here, the one they've indicated, so it's jolly nice of them, isn't it? Essentially this looks like a high level trig problem. So in order to find this angle I need to find this side. Look, notice they say SRQ, so this one is acute, so it's drawn acute. So remember, when you use a sine rule you get 2 different angles. You can have either the obtuse or an acute. This is the acute. This is the one your calculator will give you naturally anyway, so that makes things slightly easier. So to find length SQ I'm going to use the cosine rule. So it's on the formula sheet, so a squared equals b squared plus c squared minus 2bc cos a. So just simply add the numbers in. So I'm going to say SQ squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times cos 120. Remember, this has got to be opposite this side you're trying to find. Stick that into the calculator and square root, and I get length SQ equals 17.436. So I'm working to a high level of 1 decimal place because I'll round it at the end. Okay, so now I've got this side, so it's 17.436. I can find that angle, and then once I've found that angle, because I know these 3 angles add up to 180, that one will fall out. So sine rule now. I like the sine rule, it's easy. So sine R over 17.436 equals sine 27 over 9. Rearranging that, so I'm going to times both sides by that. So, and then inverse sine, so R equals sine to the minus 1 of 17.436 times sine 27 over 9 equals, and I get 61.586 degrees, which is acute. I don't need to worry about the other ones, so that's fine. So therefore the angle we want to find, which is angle SQR, is going to be 180 minus 27 and 61.586 which equals, now I'm rounding to one decimal place, 91.4 degrees. Great, easy. Turn it over. Okay, so what we got here? So we got a cubic, we got the equation of the cubic, curve, so we've got maximum, minimum. Using differentiation, find the value b minus d. Okay, so to find these turning points, okay, these turning points are gradient 0. So if I differentiate this and put it equal to 0, I should be able to find the x, the position, i.e. in this case the a and the c, the position of where these turning points occur. So dy dx of this thing here, so 3 comes down the front, so it's 3x squared minus 27. Remember, it equals 0 at the turning points, so I can see 3x squared equals 27 divided by 3, so x squared equals 9, so x equals plus or minus 3. Okay, so this is minus 3 obviously, this is plus 3, so let's work out where b and d occur. So x equals 3. Right now I'm going to put this back into my original equation, the one up here, to find the y value. So y equals 3 cubed is 27 minus 27 times 3 is 81 plus k equals minus 54 plus k. And when x equals minus 3, y equals so what's that, minus 27 plus 81 plus k, so that equals 54 plus k. Now I want to know the difference between these two, so yb minus yd equals 54 minus 54. Notice the k's disappear. Okay, if I put k there and then minus k, they just disappear. So the answer is 108. Right. Okay, so function question. So we've got the function g embedded within f. So you've got to write that algebraically, and then we're going to find the inverse, which means rearranging, changing the subject. Again, reasonably tricky sum. So fg, let's call it x, equals, now that means replacing all the x's with the whole of the gx function. So this is 1 plus 1 over, and I'm going to replace that x with all of that. So x plus 1 over 2 now rearranging that, there's not much you can do, so if it just becomes 1 plus, remember if you divide by a fraction you flip it and times it, so this just flips over the other way, so x plus 1. Okay, and then we call that h. Now we have to find the inverse of h. So I'm simply going to sort of make x a subject, so make x, so this thing, the subject, and then I'm going to swap things around at the end. So making x subject, so the first thing I'm going to do is minus 1 from both sides, so 2 over x plus 1 equals h minus 1. Then I'm going to swap these two over, so 2 over h minus 1 equals x plus 1, and then I'm going to minus 1, so now x is the subject, x equals 2 over h minus 1 minus 1. Now remember at the end now you need to swap them over, so I'm going to x is h to the minus 1, and h becomes x Okay, so I think that's correct. Let's turn it over. A proof question. I don't particularly like this question. The first bit's really easy. So show that that equals that. So you can see that this is a difference of two squares. So that's x equals x squared minus 1, which obviously if you multiply that out it becomes x cubed minus x. So you've done that. Proving the differences between a whole number and a cube is always a multiple of 6. Now, I don't like this question because it's simply, you can't do it algebraically, you've got to do it by inspection. Okay, because these are three consecutive numbers, one of those numbers must be a multiple of 3. Equally, another number must be a multiple of 2. Okay, so you need to do it in a statement. So one of the numbers is a multiple of 3. One of numbers is a multiple of 2. Hence 2 times 3 equals 6, therefore must be a multiple of 6. Yeah, not particularly satisfying, but that's the answer.